Good afternoon, everyone, and thank you for joining today's online event, Improving Student Outcomes in Chemistry. My name's Laura, and I'm part of the chemistry team here at Cengage, and I'm really delighted to introduce our guest panelists who will be driving the conversation today, Johan Werkelin, Sminia, and Ryan Chiechi. Johan is a senior lecturer at Åbo Akademi University in Finland, where he teaches chemistry to first and second year science and engineering students. He's previously been awarded Teacher of the Year at his institution, as well as taking the lead with virtual teaching during the pandemic. Welcome, Johan. Chiechi is based at Wageningen University and Research in the Netherlands, where he teaches organic chemistry to students studying a wide range of subjects, including molecular life science, biotechnology, and food scientists. Each year, over 1,000 students study organic chemistry at WUR, which is ranked as the best higher ed institution in the Netherlands and has been for 17 years. Welcome, Chiechi.
Thank you, Laura, for this introduction. Hello, everyone.
Hello. Ryan is joining us from the US, where he's an associate professor in the Department of Chemistry at North Carolina State University. He's taught for over 10 years at the University of Groningen in the Netherlands, and he'll be drawing on this experience of teaching a plenary first-year general chemistry course during our discussions today. Ryan, welcome.
Thanks, Laura. Happy to be here.
Thank you. So before we get started, I'll just give a quick overview of today's event. We'll spend just over half an hour having a discussion where we hear from each of our speakers about their teaching experience and some of their ideas and strategies for helping their students to succeed. I'll also be asking them to share some of their top tips on delivering a successful course. This will be followed by a Q&A section where I'll ask the questions that you can submit throughout the session using the Q&A button that you should be able to see towards the bottom of your screen, as well as those that were already submitted when you registered. So thank you to everyone who's already got involved and sent us some questions in. Just a quick reminder that we'll also be recording today. So you'll see the recording come out to you in the next few days by email. And if there's anything you would like to reach out to discuss in more detail, please just get in touch. So for now, I'm going to stop sharing my screen so that you can see all the speakers and we can get the conversation started. So a good place to start, I think something that united everyone during the preparation for this session was the concept of practice and how kind of very important it is, particularly within chemistry and the areas that you teach. So Chiechi, I'll come to you first. If you would like to talk to us a little bit about how you incorporate practice opportunities and what works well for you and your students.
Yeah, sure. So at my university, we are teaching different organic chemistry courses to different study programs. And we basically start with 1 or 2 general lectures about the topics. And then after that, we have small tutorials where we have approximately 30 to 40 students and 1 teacher. So there's plenty of time for a lot of interaction. Good to tell that during these tutorials, we have a set of problems from the book or from a reader where students can practice. And then because of these small groups, there's a lot of interaction and we really make sure that students start drawing mechanisms and get immediately feedback from the teacher.
Great, thank you. Johan, same question to you. How do you kind of incorporate practice?
It's very important. We use now the Åbo platform from the Cengage chemistry by Sumdal since 3 years back now. Before we did that, we had a lot of practices incorporated by manual correcting and things like that, and it's very time consuming if you give a course for 100 students. And now with the Åbo platform, we have this auto correction implemented, and the student get instant feedback on their progress. and we find this very, very useful. I pick out some, I think that was something like 140 assignments or like questions for the students to answer during the course I give. And I launch something like 20-30 questions a week per chapter that we. So it's a big important thing to select the right questions and the right amount of questions, so it's not become too a big burden for the students. But practice is essential, yes.
Right. So it's about finding the balance between, you don't want to overwhelm them, but you want to make sure that they've got plenty of opportunities. Thank you. Ryan, what about your insight to how you would do that?
Sure. So our course was structured similar to how Chuck says, and I took a similar approach to Johan. So it was, I guess, sort of combination of the two. And that is to say that we had tutorials once a week, and these were parallel sessions taught by teaching assistants. And so the idea there was mostly for the teaching assistants to reiterate what was covered in the lecture and to help the students work through problems that they had difficulties with on a one-on-one setting. But for the practice component, I really liked the OWL component, because what I could do is assign a graded homework set, so to give them sort of an incentive to want to study, and then give them unlimited practice on these sort of procedurally generated questions that OWL does. And as Johan said, this is great because it really frees up a lot of time. And so you can invest your time sort of more wisely than in having to spend all this time grading individual quizzes or homework or whatever. And the other great thing about that is that the students were free to practice what they wanted to practice. So instead of giving them, say, a piece of paper with 10 questions or 20 practice questions or whatever on it, since it was procedurally generated, if there was a concept that they were really getting, they could skip over that, and then they could work more on the topic areas that were a little bit more challenging for them. And that's going to differ for each student, right? Especially because I was teaching a first-year course. So they're all coming in from high school with different backgrounds and different knowledge levels in the different areas.
Great, thank you. Yeah, that's something that, again, we've talked about quite a lot as a group, is that leveling up of different abilities. So Johan, maybe I could come back to you on that one, because I know you'd mentioned that you had kind of different options. So you had a track where they had more homework sets, or they could kind of do fewer and go straight to the exam on ability. So maybe you want to talk about that. How do you use it to level up?
Yeah, it's nice to be in a webinar like this. I get ideas from Chuck and Ryan and how to work in the future. But one system we invented here is that we actually have 2 different grades in the course, and the student they have to fulfill at least the lowest grade in both grades, in both scales. But the first one is based on tasks to practice to do in the OWL platform, and the other one is more like an exam based scale. So they actually sit and do the tasks at a given time, and more like a normal exam, and the one which they grade the best from, so that's their end grade in the course, and that system has gained quite some positive comments from the students, that they feel that they don't have to stress for the end exam. They can actually also get a good grade from putting down a lot of work in the course. So I like that system.
That sounds really good, and also is going to help students who maybe like to choose in how they study. So some people perform really well under pressure in the end of exams, and other people maybe want that opportunity to work kind of more spread out. So
yeah, and it gives a good incentive to put down a lot of work in the course, and they sometimes complain about that it's too much work, but they still do it, and I think they learn a lot in the progress. Yeah.
Great, thank you. Chuck, maybe you want to pick up there, because that's definitely something me and you have talked about, like how you motivate them, and assign grades and things like that. Would you like to talk us through what you do?
Yes, definitely. We have a similar system as Johan described. So during class, we practice with exercises from the book or the reader, but then as a set of homework, we present also these OWL exercises, but then from the Organic Chemistry McMurray platform. And yeah, we indeed want students to practice. So there's also an incentive. We have a set of required OWL assignments. Every tutorial, we present a new set of these required assignments. And if they score like 70% overall for these exercises, they will get a bonus point for their exam. Then there are due dates on these exercises. So we make sure that from the start, students are engaged and start practicing. So then after 3 or 4 weeks during the final exam, they already have a long period where they practiced everything. So they don't have to start studying at the end. And what we definitely see that there is a correlation between how easily or how good students get involved in these OWL exercises and the final exam grade. And I also have some statistics maybe to show you that. So during my introduction lecture, I always put on this slide for the students. On the x-axis, you can see the final exam grade. And then on the y-axis, you have this OWL score. And you can clearly see that if students score like above the 75% for the OWL assignments, then basically they're also fine for the exam. Only a few of them still don't manage to pass the course. So this is all something I show at the beginning to make sure that students realize, okay, if I start practicing from the start, this will be fine.
Mm. Do you find that having that kind of that visual, that data is, a really kind of strong motivator? How do your students respond to that kind of black and white? This will, if you do these activities, you will, do better.
Yeah, so during the start of my introduction, everyone is very quiet and they're a little bit overwhelmed, but like, okay, this organic chemistry now. But then once I put on this slide, immediately there's some interaction. Like students see, really nice correlations that some students didn't do these OWL assignments and well, they still were able to pass the exam, but well, that sounds really difficult. And so they started realizing that they have to put in some effort. And this really helps me to get all students on board from the start.
Great, thank you. I'm just going to also move on to the other slide that you prepared for us because you shared some feedback from your students about kind of the course. So I'm interested to hear a bit more about that and that kind of engagement factor. So how you engage your students on your course, and does it come down to the type of questions you're choosing, or maybe the balance that Johan was referring to between how many question sets they have? Johan, did you want to maybe chip in on that one, and kind of how you drive engagement with the resources you provide?
Well, there is in OWL for chemistry Sundal, there is this pre-lecture assignments, and I don't know if there is this sort of tasks in the other course books, but it's very good because there are like pre-lecture tasks to do, like a quiz that covers the topic of the chapter, and they are supposed to do it before they come to the first lecture. So you actually have a possibility to get them involved in the topic before the lecture starts, which also gives possibilities for relevant questions and things like that. So yeah, that's one thing. That's a good feature to have pre-lecture questions. But then I also need to use some time during the lecture to walk them through these pre-lecture questions, because always when you ask a question, there is another questions arising, and you have to deal with those. But it becomes a very good atmosphere from that you actually discuss the students' questions in the lecture. So it becomes a bit like this what you call it, swapped classrooms. I don't know the correct term.
Like a flipped learning.
Flipped learning, from that point of view. But then, not to give them too many. As a teacher, it's sometimes easy to get too enthusiastic about your topic, and the students should learn this and this and this, and you put in a lot of things there. But you really have to be careful in not give them overload of tasks to fulfill. And if it's just the right amount and the right type of questions, it becomes a very nice structure for the course, I would say.
Of course, yeah. It sounds like there's an important balance to be found there. And you're talking about not overwhelming the students, and obviously, you've got your own workload to consider. So I thought maybe I could kind of move on to that topic. And Ryan, if I come to you, because it's something we spoke about quite a lot in terms of how you use resources to most efficiently teach when you're trying to kind of manage your demands and your time. So is there anything you could talk to us about on that one?
Yeah, sure. So I actually wanted to comment a little bit on the earlier topic as well, which is to say that student engagement it's a fraught topic, because in principle these students are here at a university trying to pursue a degree, so they should be intrinsically motivated. But that in addition to all the OWL tools and stuff, which are excellent time savers, it's important that you have a good textbook. And so I was teaching out of Oxtoby Gillis, which I really, really, really like. This is an excellent textbook for general chemistry because it's put together in a way that really lends itself to sort of a narrative style of lecture, which is how I like to lecture, because so you have a lot of time constraints on you. And I feel that the advantage that the students have of getting a lecture from a professor who's also an active researcher is that you can incorporate, real cutting edge science into it. And you can tell them, look, I'm teaching you a concept that's 200 years old that I use in my research right now. And if you want to know more about that, we can always talk about it later, et cetera. I find that's a good way to drive student engagement. But then on the flip side of that, you got to spend a lot of time doing research and sitting in committees and doing all kind of boring stuff like this. So you don't have a lot of time to pour into, building big elaborate homework sets and all this kind of stuff that you'd love to do if you had the time to do it. And so the way that I structure the course is very similar to what Johan said, which is that we went through one chapter a week. It was a pretty easy pace. And at the beginning of the week, I would release the practice for the whole chapter. And I would encourage the students to do it before the lecture and say, these are practice questions. They're not graded. This is for you to evaluate where you stand with the content that we're going to go through this week. And if you go through the practice and this is really easy for you, then you know what, come to lecture and, you'll get the added benefit of all the stories that I tell and my gesticulating and all this sort of, this is the added value for you. If you go through the content at the beginning of the week and it's really difficult for you, you really need to focus on the tutorials. You need to sit with your teaching assistant. You need to go through the questions and figure out why this is difficult for you. And I found that even the sort of recalcitrant students, they would do this. After a couple of weeks, they would realize that if you do the practice questions at the beginning of the week, then the homework assignments at the end of the week were actually very easy because it was the same sort of style of problem. This is an enormous time saver for me because since this all happens sort of automatically in the ether, I was then able to interact with the students one-on-one, which is great because you always have this kind of highly motivated cohort in the course, who can really get a lot more out of it. And they would come to my office and we would have, emails back and forth and such. And I thought this was a great way to take care of sort of the, I just want to put my head down and get through this course kind of cohort. Also to help to, bring up the people who are just struggling because they came from, a background that didn't really emphasize the stuff that we're teaching, but then also to have that one-on-one interaction with, sort of I hesitate to use the word top students, but the most highly motivated students who maybe have seen a lot of this stuff in high school. So it's kind of easier for them. And I wanted them to get something out of the course as well. And I thought that combination, it took a few years actually to dial everything in just right. But once we got it in there, I thought it would, and we saw the pass rates come up, and we saw, the average grade shift up and everything as this engagement sort of got better. And I think that being able to push the kind of menial task of grading everybody's homework sets onto a computer really, really helps, because it frees up so much time. But I don't feel like you lose anything. I mean, there's no added value in me going through and grading each problem myself, right?
Definitely. Thank you. That was such a good overview of how you are kind of capturing each level of student. So yeah, I'd love to know if Chirk or Johan, you've kind of got any comments on that as well, that kind of how you keep track of people and make sure that everyone is where they should be.
Do you want to start, Chirk?
Yeah, sure. Well, first, a comment what you made, Johan, about this flipped classroom approach. We definitely also use that. So before students come to my lectures or tutorials, we ask them to watch knowledge clips or like these pre-recorded presentations with audio slides. So that, yeah, during the tutorials, there is time for interaction and for these stories where Ryan was talking about, rather than going through all the basics again. And yeah, that's what I wanted to comment on what Johan just said.
Yeah, I think it sounds really interesting with these tutorials you use, Chirk and Ryan. We have had similar sort of, we call them like clinics. So where older students help these first year students to fulfill the tasks we give them. So maybe that's some similar kind of tutorials. But I would like to emphasize actually the lab practices, which we give also with all our chemistry courses in the basic level. So every week the students come to the laboratory, the course laboratory, and they do a laboratory assignment which we prepared for them, and there you really have the chance to discuss and meet with the student, get the temperature of how things are going, and it's also very easy to go to your OWL score and see how many credits they have managed to pick so far, and you can easily ask them also, like, well, how is it going, and so on. And also, like Ryan says, that the more motivated students, they want to know much more than what's just in the course book, and they want to know also the things that they see in the lab, and discuss their results and such. So it's a very good place for really connecting and interrogating with the students, the lab practice. So I'm very happy that the faculty still thinks that it's worthwhile to have this sort of teaching in our university. Yes.
Yeah, I want to reiterate that being able to follow the grades, and I mean, not the grades, but the scores in real time is also very important, because it allows you indeed to track how each cohort is doing at that time relative to the previous cohorts at that time. So you can also see if because batch to batch, the cohorts are a little different and they progress a little bit differently. And I like to take sort of a, because these are first year students, is their first experience with the university. So I like to scare them a little bit. And so when they, just to let them know that this is serious, right? Because I find sometimes when students come from high school is really oriented around the student. Universities are not, and they need to learn that that important lesson in their first course. And I don't mean to say that we don't serve the students well. I'm just saying that the institution that is the university doesn't exist solely for their benefit, like high school does. And so what I will do is I have a grading scheme that's similar to Chirk's and Johan's. I think also you both do something similar, which is to say that we break it up between homework, midterm, like quizzes, final exam, whatever. And at the end, you can basically drop the lowest score on those things off of your final grade, and then we weight them appropriate to kind of, how important they are in the course. And so at any given time during the course, if a student emails me and says, how am I doing? Am I passing the course? I can honestly say, well, I don't know, because I can't compute your grade until you finish the course. And I like this because it puts a little bit of fear into them. They say, no, but tell me how I'm doing. Really, am I going to pass this course? And I say, well, how did you do on the homework? How are you doing on the practice sessions? What kind of scores are you getting on your quizzes in the tutorials? I'm like, oh, well, I'm getting all like, 8s and 9s on those. It's like, well, then, I think you're probably doing well in the course. They said, but am I going to pass? I don't know. And it keeps them, it keeps them a little bit motivated. But what I like, of course, is that I can just pull up a spreadsheet and look and see exactly how they're doing. And when I'm talking to them, I know, compared to previous cohorts and, just with the experience, whether they're likely to pass or not, and I can treat them appropriately.
Thank you. So a question off the back of that is, would you use that overview or that data if you checked in and said, oh, this week it's not been great? Would it change what you taught? Would you, revisit something? Would you, does it have that impact on your teaching?
Yes. So every week we have a meeting with all the teaching assistants, and I go over the scores from the previous week, and I identify which students probably need a little extra attention. I also sometimes just the whole cohort is blowing through the material, and so we'll adjust the difficulty a little bit, or maybe add some content, or maybe do something a little bit of added content that maybe goes a little bit beyond the textbook or something, or the reverse. If the cohort's struggling, then we'll back off a little bit and really trying to focus on the fundamentals.
Great, thank you. Does that resonate with Chiechi at all, or Johan, in terms of that ability to react, Chiechi?
Yeah, so this OWL platform has a very nice grade center where you can easily track the student's progress and indeed intervene if necessary. Or if a student approaches you and like, hey, I had some difficulties, can you reset the due date? Maybe this is easily done. And also for transparency, you can easily export this OWL gradebook into another platform, a learning system platform like Brightspace, for example, we are using at my institute. Mm-hmm. So that also gives the student a very nice overview. How am I doing and what do I need to do in order to pass the course?
Great, thank you. Johan, did you have?
And of course, each student can see in their own OWL platform how many points they got and so. But I have I also export this data into Excel and have calculated there. So and I update that information for the student each week, so they know how they are progressing. And I think that's actually an important part of this system, that they can see for each week how their progress is, and that they know that, okay, now I maybe need to give some more effort to this, or so yeah, it's an important thing, definitely, I would say.
Thank you. Yeah, it seems like that's something that's kind of resonated around the group, the importance to your visual as the instructor, but also for the students to kind of keep track of where they're going. So we have quite a few questions coming in, and we had a few before the session as well. So before we move on to those, I just wanted to do a bit of a round robin as to, you're all running successful courses that are going really well. So what would be your kind of top takeaway, your top tip for kind of getting the best out of your students, really? So Ryan, if I came back to you to start that one.
I mean, this is sort of, I think, maybe specific to my style of teaching, but as I said before, I think that the most advantageous part of using, the OWL platform and all this stuff to support it is that it frees me up to give more engaging lectures. I don't have to, I can look and I can see, okay, the students are struggling here or whatever. We get this real-time feedback, but I don't have to worry about that so much, because I can adjust the problem sets and such. And I can, like I said, I can meet with the teaching assistants. It's very easy because we're not working off of fixed paper and pencil sort of, buckets of questions that we draw from or whatever, that we can really generate these things in real time and monitor the progress in real time. So that frees me up to give more engaging lectures. And that's feedback I get from the students, is that they like having an energetic lecturer. And especially in the beginning, I mean, if I were teaching some advanced PChem course or something, I'd probably be on the board with a piece of chalk. I am on the board with a piece of chalk much more often. But when you're teaching younger students, I think it's important to be energetic and to be engaging and to tell stories and, to walk up to them in the lecture hall and make eye contact and, make them squirm a little bit in their chair and crack jokes and things to keep them really engaged. And I feel that, in let's call the old way of teaching, sometimes you were less free to do that because you were really burdened with this idea of like, oh, my pass rate's dropping and I have to go, I have to go put out little fires and I have to make sure that in lecture I cover this stuff so they can pass know how to do these questions on the exam. But I don't have to worry about that because I know that they have infinite practice. And at the beginning of the lecture, I can simply say, I have a tip for all of you that, might want to pass the exam. You should probably practice this, 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 and this, and this in this week's practice session. And that's all I have to do. And then I move on and I give my regular lecture. And I really like that. I like that it frees me up to continue, to really focus on the presentation, the showmanship, I guess, of giving lectures.
Great, thank you. That's a really, really lovely insight. Just before I move on, one of the questions that has come in is very relevant. And they're just asking Ryan about your the correlation between how many teaching assistants you have for your course compared to the size of this the student cohort.
Ah, yes, the eternal question.
Yes.
This, at least at the University of Groningen, was a contentious issue having to do with the way PhD students' contracts work versus scholarship students, et cetera. So we were always a little bit under-resourced with teaching assistants, but we're also really space constrained. And so we had to run the teaching, the sections, the tutorials rather, in parallel. And so basically what they would do is they would find out how many rooms we have, what the capacity of that, or how many we have in the total cohort, how many rooms we have that, if we divide into, say, 30, we can fit them in that many rooms. That's how many TAs you get. It's bound to how many rooms you get. And there is a strong correlation between the TA to student ratio and the success of the course, because the TAs get to know the students on a real one-on-one individual level every week in the tutorials in a way that you just can't do it in a in a lecture hall with 300 students in it. And as I said, I just simply lack the time to engage with the students at that level. So it's very important that the teaching assistants get to do that we meet every week and that we discuss how the students are interacting with the teaching assistants. Sometimes we even have to swap students around because they don't get they disagree with a particular teaching assistant, or their personalities don't match or something. But once you get that dialed in and you get that kind of mutual trust, and you have a relatively small cohort per teaching assistant, then yeah, it just scales with the teacher student ratio at that point.
Great, thank you. Interesting to hear that kind of relationship is also really important too. Johan,
can I comment on that one? Because what you heard already from me, we don't have this system, but it sounds interesting and very good. But what I do is that I encourage the students strongly to cooperate in all parts of their studies, because it makes things so much more fun and also helps with a social well-being and everything. So I'm very clear about this when I give a course that you should cooperate in almost all parts of your studies except in the exam, because then you are on your own. But that's something we have now a new house in our campus, and it's lovely. It's full of small rooms where people can sit in groups and work together. So there's no lack of room in rooms in our campus anymore, and that's a good thing. Yeah, cooperation.
Great. Yeah, that peer-to-peer learning, really important. Chuck, if I come to you, was there any kind of last thoughts or contributions in terms of what's really made the difference to your course that you have to share?
Yeah, maybe to comment on what Johan and Ryan already said about the lab practicals, for example, that besides our next to our tutorials, we also have these practicals where we divide indeed the groups into smaller groups with teaching assistants. So one teaching assistant is supervising 10 students in the lab. So again, plenty of time to interact. But that of course needs some resources, as well as space in the labs, because we have over 1,000 students every year.
Awesome. And also a couple of the questions that have come in, I'm also going to direct straight to you, Chiechi. So the first one is asking about how similar your exam is to the exercises in OWL. So yeah, if you could talk to us about that a little bit.
Yeah, that's a very good question. So yeah, our OWL assignments are of the same level as of the exam, and we also try to take the same approach in the type of questioning. Of course, if you have the OWL platform is of course digital online, while we have handwritten exams mostly. So there is some translation needed, but in general, we try to aim for the same level as the OWL exercises and the same type of questioning.
Great, thank you. And another one for you, because it's on a similar vein. Someone's asked about specifically organic chemistry and whether you have any challenges in terms of covering everything. Huge amount to cover in that kind of first year, and if I think it was about the level of students, so you've got a huge amount to cover, you don't want to miss anything out, but you might have students that don't have maybe the background knowledge that others have. I know we talked about it a little bit already, but anything else to kind of comment on that coverage?
Yeah, for the first year students, we also have refresher courses in organic chemistry. So if their level from the start is not the same compared to the others, they can follow these extra classes. And then again, this OWL platform is a great resource. So students get, next to the required assignments, they also have plenty of opportunity to practice with an additional set. And yeah, making all these exercises will give them the correct level which is needed for the exam in the end.
Great, thank you. So you're really supporting them with those kind of, as much as they need, essentially, to kind of get them up to level.
Yes, definitely.
Great, thank you. So I'm just going to jump to another one of the questions, which was, how have you approached improving students' critical thinking? So Johan, any thoughts on critical thinking?
Critical thinking, yes. I like to teach from a concept which I think it has a nice name, but I don't know what that is. But it's like you start from misconceptions, misunderstandings, because there are so many misunderstandings when it comes to general chemistry learning and teaching and concepts. So I usually have a quiz in the beginning of each lecture where I test the students, and I love them to make errors there because it's a good starting point. Many students that come to university to study science, they have this idea that they are pretty strong in this area, and then they come to a general chemistry course and they have this impression that, well, this is piece of cake and I maybe don't even need to go to the lectures, and then I try to a little bit give them a vision of there is so much to learn and there is so much to understand, and this stuff is actually very interesting and fun. So this is the starting point I try. And I think from this comes also the critical thinking, that you can be critical also to your own learning process and your own knowledge. And I think it's a good starting point from
Can you anticipate what the the kind of mistakes that you're expecting? Are they often kind of common misconceptions, so you can kind of prepare for what they're going to do? Or do you find that, you know, it really highlights a whole range of misconceptions that your students might have?
No, but if you take a concept like the gas law, for instance, that there are so many things when it comes to gases that you have idea about how it works, and well, you can ask a question. The student, if you ask the students what is the exhaust gas coming out of a car, what does it consist of, for instance? So they have this horror idea that the most of the things that comes out of a exhaust pipe is the really poisonous compounds like NOx and carbon monoxide, because that's what everybody talks about. They don't realize that 80% of the exhaust gas is actually nitrogen. And that's one good thing to start with when you start to talk about gases and mixtures and concentrations and things like that. So yeah, I try to pick those. Well, I'm from a research point of view, I'm within this combustion inorganic chemistry side. So it's my topic. So it's easy to start there.
Definitely, yeah. Drawing on your research makes a lot of sense. Thank you. Any thoughts from Ryan or Chirk on that critical thinking question?
Well, I think Johan took a definition of critical thinking here, because that's a bit of a nebulous term that I fully agree with, which is to take the concepts that you learn and be able to then map them onto problems that aren't obviously associated with those concepts. So I think the car exhaust is an excellent example of that, where it's like, look, we're studying gas laws, we're studying stoichiometry. So can you put those things together and reason what might be coming out of a tailpipe? And in order to get to that answer, you have to think about, well, what's the starting point here, right? It's not just gasoline, it's the air around it, which is mostly nitrogen. And so that's probably going to be the bulk of what comes out of the tailpipe. And I think the way to do that is to, you have to balance teaching them kind of rote sort of, not memorization, but like algorithmic sort of processing, right? Of like how to balance an electrochemical equation or something. Like, you just have to learn how to do these things, and you have to practice until you do it. But the trick is then being able to anchor that in some other concept somewhere else, so that they can take that knowledge and then apply it elsewhere. Because there's, otherwise they get into this trap. And I mean, organic chemistry is famous for this, of trying to memorize everything. And you can't. There's too much to memorize. At a certain point, you need to make that leap to, okay, well, I can intuit how this reaction is going to go based on the functional groups involved, the different electronegativities, the orbital structure, all these things that I learned in my organic chemistry course. And I don't have a good answer for it, because that's a fundamental challenge. I really like Johan's exhaust example. I think that anytime you can find specific links like that, that is fantastic, right? So because of my interests, when I'm teaching general chemistry, I'll be talking about something from a century ago and some weird concept like this, and I'll try to ground it in like mobile phone technology. And I'll say, this thing is in your mobile phone right now. Can someone tell me, like, why did I suddenly jump to the display on your phone that you're staring at instead of paying attention to me? And try to get them to reason backwards to why I might have made that link. But everybody does it differently, and that's a very tricky one.
It is, yeah, but it's really interesting to hear your thoughts and how you kind of make things very relevant to the students, which I imagine goes down very well. Chirk, did you have anything to add about how you kind of take students beyond concepts?
Well, I think it's definitely important to get students out of their comfort zone every now and then, because then they start learning a concept, a new discipline. And what we, for example, have is that during the practicals, all students do individually their practical. And that definitely stimulates critical thinking and applying the concepts they just learned during the tutorials or the lectures. And then, because we have such small groups, there's good interaction, cooperation, because of course you need that as well. And then students start taking responsibility and start this critical thinking concept.
Great, Thank you. I think we could probably talk about some of these topics all day, and but we are kind of at the end of our time now, and we've got through most of your questions in the Q&A. There were a couple of specifics about our platform and some of the textbooks that have been mentioned, so I'll be sure to follow up on those. I just
Can I add one thing? Sorry.
Yeah, no.
Because we mentioned the OWL platform a lot, and I just wanted to say, for like anyone who's curious about it, one of the things that I really, really appreciated about it is Stuart. I don't know if he's still in charge of everything, but he is a centralized person who you can email directly and get support. So when you're trying to bring your course online at the beginning of the year, and we used Blackboard, for example, and your Blackboard is malfunctioning and you can't get the Cengage module going, you don't have to call a support line and sit on hold or like whatever. You email Stuart and he just fixes it. And that I cannot overstate how useful that actually is, being able to interact directly with somebody who is extremely knowledgeable and can fix problems, because that is one of the things that's difficult with a lot of these digital platforms, is that they're part of some giant organization, and things go wrong. And when they go wrong right before a course goes live, that is just a nightmare. Walking into the first lecture and saying, hey, you're supposed to have all this work online, but whatever. I mean, the students are unforgiving. It sets the whole course back, et cetera. And so this is one of the added values of this specific digital platform, is the singular human being, Stuart, who can field your questions, who can fix things in real time, who is extremely responsive by email, who will jump on a Zoom call with you to work things through while you're tearing your hair out an hour before your lecture starts.
Thank you for that glowing endorsement. I'll be sure to make sure Stuart, if he isn't watching, watches this. There is a Stuart for all of the regions that we work with, so it may not be Stuart, but yeah, we have someone helping out in all of our different regions. And as you say, I can see the value when you're ready to go and your students are kind of expecting things. So yeah, just a final thank you so much to our speakers. Thank you, Johan, Ryan and Chirk, for joining us today. It's been really fascinating for me, and I hope everyone who joined us today has really gained a lot from this session. As I've already said, I'll be sending up follow-up to anyone who's asked any specific questions. And of course, if you want to know anything about anything we talked about today, please do get in touch. Thank you very much, everybody.